Good morning, everybody. Now, let's start with some different cases of analysis of struts as a compression member. In previous lecture, we have understand about the simple case of analysis of strut. In that case, we have understand that whenever load is applied on the strut, that is concentrically. But now we are going to understand the load applied on the strut, that is eccentrically. In which case the eccentrically load is applied. So in that case we have to just think that whenever our strut is unequal leg angle, in that case generally eccentrically load is applied. So what happened? For the understanding, I have taken here one example, and that is calculate the compressive strength of a single angle strut ISA 100 by 75 by 10 mm with center to center length of 1.5 meter. Angle is loaded through one leg, that's why it is eccentrically, and are fixed, considered one bolt at each end. Take Fy is equal to 250 megapascal. So here we have angle as a strut, that is 100 by 75 by 10 mm. So for that we have to take the values of area and R minimum from the steel table, and area for this section, that is 1650 mm square, and R minimum, that is RVV 15.8 mm, that is given in steel table. So from this value we are getting the effective area of the strut, and for that we have to classify the section, and that section classification is given on page number 18 IS 800, and the strain that is given in page number 18 not number 2. The value of epsilon, that is 1 for the Fy 250. Now the section selection for the compression member as an angle, then it is B upon T. So 75 upon 10, that is 7.5, which is less than 15.7 epsilon. Second, D upon T, 100 by 10, that is 10, which is less than 15.7 epsilon. And third one, that is B plus D upon T, that is 175 by 10, it is 17.5, which is less than 25 epsilon. Now this all three value is less than the given limited value as a semi compact on page number 18. So we can consider that our section is semi compact. So gross area is equal to effective area. Let's see, since all the three conditions criteria are satisfied, the section is semi compact, that's why Ag is equal to A, and that is 1650 mm square. Now load is eccentric, as we discussed. Equivalent slenderness ratio must be taken, and that lambda E is given on page number 48 IS 800 2007, and value of this K1, K2, K3 is given on table 12 on that page. So lambda E is equal to under root of K1 plus K2 into lambda VV square plus K3 into lambda phi square. So we have to finding out this K1, K2, K3 and lambda VV and lambda phi, and for that we have equations and K1, K2, K3 which is depending on the condition. Which condition? For the fixed end condition and having one bolt of each end, so we can take K1, K2, K3 as per that. So K1 is equal to 0.75, K2 is equal to 0.35 and K3 is equal to 20. Now lambda VV and lambda phi, so we have equation for that. Lambda VV is equal to N upon RVV upon epsilon under root of pi square E upon 250. So we have to first of all length over here. So that length is given in our question, that is 1500 mm. So put this all value. So we will get lambda VV as a 1.07. Now the lambda phi. So for that we have equation B1 plus B2 upon 2t divided by epsilon under root of pi square E upon 250. So the value after putting we will get it is 0.098. Now we have all 5 value. So put it value in this equation. Lambda E is equal to under root of 0.75 plus 0.35 into 1.07 square plus 20 into 0.098 square. So we will get lambda E is equal to 1.16. Now in our all the equations that is depending on lambda, in that case we have to put lambda E instead of that lambda. So the imperfection factor alpha, that is given on page number 35, and alpha is totally depending on buckling class as we know. So it is 0.49 for an angle. So phi is equal to 0.51 plus alpha in the bracket lambda minus 0.2 plus lambda square. This lambda is our lambda E. So after putting the value we will get 1.41 as a phi. Now we have the equation of that FCD which is given on page number 34 IS 800, and in that case we have the equation which is depending on phi and lambda. So this is our equation. After putting the value, Fi is equal to 250, phi is equal to 1.41 and lambda is equal to 1.16 divided by gamma m0. We have the value of gamma m0 that is given on page number 30. So after putting the all value we will get the FCD, and that FCD is equal to 102.27 Newton per mm square. So now FCD we have, and area, effective area we have. So design compressive strength PD is equal to E into FCD, and that PD we will get, that is 168,745.5 Newton, and this is in Newton. We have to must convert it in kilonewton. So PD is equal to 168.75 kilonewton. So whenever this angle as a strut we are using, it is take up to 168.75 kilonewton force as a compressive force. Clear? Now we have some different case. A double angle discontinuous struts made of 2 ISA 80 by 80 by 6 mm placed back to back on either side of gusset plate. This is our gusset plate, and back to back two angles are connected with 80 by 80 by 6, and the thickness of gusset plate, that is 10 mm, and tack bolted. As we know, the length of the member is 3 meter between intersection, means total length at joint, that is 3 meter. Determine the compressive capacity of this member. हमें इसके लिए compressive strength find करनी है, ये कितना compressive force ले सकेगा. Assume the grade, that is Fe410, steel with Fy 250 megapascal. So, whenever we have this kind of section, we have to consider that the section must be take force as a concentrically. So, we can finding out the FCD from the directly page number 42 of IS 800/2007. Now, what we have to do for the 2 ISA 80 by 80 by 6 mm area, that is 1858 mm square, RZZ 24.6, RYY 36.3 for the 10 mm thick gusset plate. So, R minimum is equal to 24.6. Now, effective length for this case, and effective length that is depending on KL, and K is equal to 0.85 that given in code. So, the effective length is 0.85 into 3000, it is 2550 mm. Now, what is happening over here? KL upon R, that is 2550 upon 24.6, so it is 103.65. Now, this KL upon R is used for finding out the FCD for our angle section, and for that we have to see page number 42 in IS 800/2007. From that, after the interpolation of the value, we will get the FCD for this KL upon R. So, design compressive stress FCD is equal to, from the table 9C in IS 800/2007, for this KL upon R 103.65 and FY 250 value lies between 10. So, it is for the difference of 10, it is 12.5. For the 3.65, what will happen? It is 4.53. So, FCD is 102.47 Newton per mm square. Now, design compressive strength PD is equal to A into FCD, that we know. So, we have the area, that is 1858 plus, multiply with 102.47. So, we will get this PD. It is 109.38 kilonewton for the double angle. Got it? Now, next, a double angle discontinuous struts consists of 2 ISA 80 by 80 by 6 mm placed on the same side of gusset plate. Whenever it is on same side, then there is no concentric, that is eccentric, and we have to calculate that angle as a single angle. After that, multiply with the double. Tack bolted, the length of the member is 3 meter between the intersection. Determine the compression capacity of the member. Assume the grade 410 for steel with FY 250 and it is hinged at both ends. Now, in this case, it shall be treated as a two separate angle because it is the same side on gusset plate. So, loaded through one leg and it is eccentric loading. So, calculation must be for a single angle. For single angle ISA 80 by 80 by 6, area and R minimum we will get from the steel table. Now, for the effective area, we have to classify our section. B upon T is equal to 80 upon 6, which is 13.33, which is less than 15.7. D upon T, that is 13.33, it is less than 15.7. B upon T, it is 160 upon 6, it is 26.69. It is not less than 25. So, our section is slender. We are not allowing the slender section as a compression member. It will be buckled. So, now we have to revise this value and satisfy this condition. So, it must be less than 25 epsilon. So, the value, since all three conditions are not satisfied, the effective cross sectional area is to be used as a reduced. So, यहाँ पे हम क्या सोचेंगे, B प्लस टी अपॉन टी वो 24 एप्सिलॉन होना चाहिए, लेस देन 25। सो अगर हम ये 24 लेंगे तो क्या होगा, B प्लस डी अपन, थिकनेस तो हमारी 6 फिक्स ही है, सो B प्लस डी कितना होगा 144। सो एक डायरेक्शन में 80 की जगह हमारा यूजफुल जो एरिया है वो कंप्रेसिव फोर्स ले सकता है, दैट इज 72। यानी इतना सेक्शन वहाँ पे है बट वो फोर्स कैरी नहीं कर पाएगा, यानी हमारा एरिया अब इफेक्टिव एरिया इतना ही रहेगा। क्लियर? सो इफेक्टिव एरिया ऑफ दिस सेक्शन मस्ट बी रिड्यूस्ड एंड इट इज 828 mm²। Whenever we have this kind of question, we must have to consider that effective area as a reduced area। यानी जो पूरा सेक्शन हम यूज़ कर रहे हैं वो पूरा सेक्शन हमारा फोर्स नहीं ले पाएगा, उसमें से थोड़ा सा एरिया जो है वो हम निकाल देंगे इन द सेंस वो वहाँ पे ही रहेगा, लेकिन हमारा एरिया जो है वो फोर्स लेगा वो रिड्यूस्ड हो जाएगा। गॉट इट? समझे आप? चलो तो आगे बढ़ते हैं। नाउ एज वी नो इट इज एसेंट्रिक, दैट्स वाई वी हैव टू फाइंडिंग आउट द इफेक्टिव लैम्बडा, and for that we have equation that is under root of k1 plus k2 into lambda vv square plus k3 into lambda phi square. It is given page number 48. Consider one bolt at each end hinge. It is the k, we can get the value of k1 k2 k3 from the page number 48. We have the length that is 3000. Now lambda vv have and lambda phi, we have equation for that, that is lambda upon rvv upon epsilon under root of pi square e upon 250, that is 3000 divided by 15.6. It is 1 into under root of pi square 2 into 10 raised to 5 divided by 250 is equal to 192.3088.6 divided by that is 2.164 as a lambda vv. And after putting this b1 and b2 we will get the value of that lambda phi, that is 13.33 upon 88.86, this is 0.15. Now we have these two value, put this all 5 value in this equation and we will get the effective lambda, means effective slenderness ratio for our section, that is 2.222 after putting the all value. Now हमें क्या फाइंड करना है, अल्फा, एंड दिस अल्फा इज गिवन ऑन पेज नंबर 35 एंड फॉर दैट it is totally depending on the buckling class, and buckling class is given on page number 46. So we will get the alpha, that is 0.49, and phi, we have the equation for this phi which given on page number 34. It is 0.5 under root of 1 plus alpha lambda minus 0.2 plus lambda square. So we will get phi as a 3.464. Now we have to finding out the FCD, and for FCD we are going to finding out the x. So it is 1 upon 1 plus phi square minus lambda square. We have these two value, putting the two value and we will get x is equal to 1.63. Now we have actual equation, that is fy upon phi plus phi square माइनस लैम्डा स्क्वायर अपॉन गैमा एन, वहाँ से हमने ये पार्ट अलग कर दिया, उसको एक्स बोल दिया है। नाउ डिजाइन कंप्रेसिव स्ट्रेस एफसीडी, दैट इज एफसीडी इज इक्वल टू एक्स इंटू एफ अपॉन गैमा एम 0. सो वी विल गेट एफसीडी, दैट इज 37.04 न्यूटन पर mm square. नाउ द डिजाइन कंप्रेसिव स्ट्रेंथ, that is PD is equal to AE into FCD. We have this AE and we have FCD, so it is 30.669 kilonewton is a compressive force. Clear? So we have two ISA, so PD is equal to AE into FCD, and actually that is 30.67. So, for 2 ISA it is multiplied with 2, that is 61.34 kilonewton. So, this much force only can taken by the our section. So, it is very much difficult to consider that whenever our section is eccentric, then the capacity of taking the compressive load it is reduced. Clear, student? Now, in the next lecture we are going to understand about the design of member and the compression member as a column, and it is for the I section or built up section is discussed in next lecture. Thank you so much.